Hi guys, this is Enno from the Xzistor lab, and in this demo video we will see how the Xzistor concept brain model can generate pain and fear in the mind of a robot. In this video we will look at how we simulated pain the first time in one of the very first simulations we did for the to prove the Xzistor concept, a little model called Simi, and we'll just look at how we modeled pain in the 3D virtual environment. Secondly, we'll look at the simple rules we use when the robot is going to collide with a wall and it's going to generate pain. Thirdly, we will look at the actual physical robot and how we've implemented pain and fear in the robot. And then we will just finally look at how pain works in the brain, and how it enables us to also model fear in the brain. So the robot will experience pain, but it will also learn from that and then experience fear in future. So I think the interesting thing about pain was, once we got the Xzistor concept running, the one thing that was still eluding us was pain. And for the life of me, I couldn't figure out where pain was being generated in the brain, and it literally took me 2 years, endless tests, to find out where pain was hiding. And I remember at the time how I was pinching my leg and trying to think, how is this working? What's happening when I feel pain? And interestingly, why when I was rubbing my leg the pain would go away, or why that felt better. So that gave me a clue, and I think the question there was, how was it that tactile action of rubbing the area where I pinched myself would make me feel better and interfere with the pain signals? So clearly some part of our pain algorithm was hidden in the tactile zone of the brain, because touching the area could interfere with it. And I think that sort of helped me, and suddenly everything fell in place. And the nice thing about it was there were absolutely no changes to the model were required. I could use exactly the same basic building blocks that I use for everything else in the Xzistor concept brain model to produce pain. So now the Xzistor concept brain model was complete, and pain's elusive spell was broken, and that literally, like I said, it took me 2 years after I've developed the whole model to find out how pain worked, and in the end it was a very simple solution to just use the existing concept as it was, and just to add an algorithm just along the same lines of all the other algorithms. So we say no changes to the brain model was required. This also meant that the association forming algorithm could use pain via the emotion algorithm to create the fear of pain. And the fear of pain allowed a robot to learn not to bump into walls and obviously avoid other obstacles. Just to make it clear at this stage, the fear of pain is but one of many types of fear. A lot of human behaviors are driven by fear. With the current definitions I see of fear on the internet, it's very difficult to try and discern between the different types of fear. What is very nice about the Xzistor concept brain model is that it defines a single term which actually explains all types of fear. So whether it's the fear of pain, or whether it's a fear of losing an opportunity, or fear of embarrassing yourself, or fear of losing a potential source of income or pleasure. In the Xzistor concept brain model, these are all defined by a single term, let's say ABC, and it really simplifies, and then you can define it obviously in mathematical terms. So first, just the tactile touch. We have the robot bump into a wall, for instance. And we will first record just tactile touch. So before we say the robot's going to experience any pain, we just say, okay, you're touching the wall now. It's only if we increase the pressure that we will send a different type of signal to the robot. Say, this is now pressure, this is more than just touch. And obviously if the pressure is high enough or the impact is high enough, we will say, okay, that is pain, and that is the type of signals we will send through. And this was successfully built into this demonstration, this semi-robot that we will demonstrate shortly in this 3D simulation. So we'll switch over to the 3D simulation now, and we'll just talk a little bit about the how the pain was modeled in that simulation and how it all worked. Here we have Troopy's virtual ancestor, a little robot called Simi. In his virtual learning confine. He's now turning towards the cactus, and he's going to move in the direction of the cactus. And when he comes in contact with the cactus, we will see what the reaction is. And there's a quick reflex to move away from the cactus. So if we just take a look in slow motion, we'll see above his head on the emotion panel those little brown bars. That's indicating fear, and we can see the fear increases as it gets closer to the cactus. And this shows us that he's encountered the cactus before, and he's actually learned that the cactus can cause pain. So that's the fear bars there. And there we see when he's in contact, fear maximum, and the red is the pain that he's actually feeling. And just the green antenna on his head, let's have a chat about that. So the green antenna on top of Simi's head helps us to discern the distance that the robot is from any object like the cactus or the walls of the confine. So when he's not close to any object, the red bar inside, which almost looks like a thermometer, the red bar will be in the green area of the antenna. When he's touching a wall or feeling some pressure, the red bar inside will move into the yellow area of the antenna. And when he feels pain, the red bar will actually protrude out on top of the antenna. And this helps us to discern the distance that the robot is from his side walls or the cactus, which is not always that easy to see on the simulation. And what we do is we use a few simple rules in terms of the distance that the robot is from his confined walls. If we look at that image there with a confined wall is the black line there. If we come over to the left and we see the green area, this is where the robot is still some considerable distance from the wall. And that's where we say he will just feel a tactile sense, so he'll just feel he's touching something. When he gets a bit closer to the wall, he'll feel pressure, start to feel pressure. And when he's right up close against the black line, that means he's so close to the wall that he's feeling pain. And that's a simple way to just model first of all tactile, then pressure, and then pain as the robot moves into any object. In the virtual simulation, the simulation, we have modeled this comprehensively and tested it quite comprehensively. And perhaps we can just quickly take a look again at Simi, and this time we focus on the antenna and just look at how that red bar moves up into the antenna as it gets closer to the cactus. And after that, we'll take a look at how we modeled pain and fear in a physical robot. Now let's see what happens when a physical robot approaches a wall. This is Troopy moving towards the black line, which is the wall. And we see exactly the same reaction as with the virtual simulation. When Troopy moves backwards towards the black line, which is the wall in this case, exactly we see the same reaction. And we'll now take a look at the physical sensors that we use to model pain and fear in a physical robot. There are many different sensors that we can use when we want the physical robot to sense the proximity of the confined wall. This is the Lego sensor. It's basically an on-off switch, and it'll tell the robot that it has made contact with the confined wall, but not what the pressure is. More recently, I've seen this switch online. It is a combined force and on-off switch, or a sensor. It measures up to 10 newtons in force. That's the equivalent of about 1 kilogram in weight. And with this sensor, we can actually tell the robot what the pressure is as well. I have looked at quite a few different types of sensors. there's different ultrasound sensors, lasers and radars and other cameras. The problem with this type of sensor was when the approach angle with the confined wall becomes too steep, the repeatability reduces. And that was a problem for me, because at this stage where I was testing the integration with the other algorithms of the brain model, it was very important to have very exact data on where the robot is and how far it is from the confined wall. So in the end, I actually settled for using the Lego color sensor, and this was for the sake of repeatability, and I used it in combination with some color patterns on the confined floor. And if we just look at these patterns, there's the Troopy's confined floor. The thick black ring is actually the physical wall, and when the color sensor moves onto that, it'll tell the robot that it is now physically in contact with the wall. The red inner ring is the touch or the tactile ring, and that will just tell the robot it is just making contact with the wall, and it doesn't feel pain yet. If it moves onto the black area, we will tell the robot that it's now sensing pain. The black bulbous area towards the top of the thick black ring, this is where we've positioned the cactus, and there we see there's no tactile warning around the cactus. There's no red line there, so when the robot moves onto that area, it'll immediately feel very sharp pain with no tactile warning before that, and that's how we modeled the effect of the cactus in the confine. So let's take a look now at Troopy again in the confine, and we'll see what happens when the color sensors move onto the thick black line. So here we see the dashboard where the Xzistor concept is running on the laptop. And of course the laptop is communicating with Troopy, the little Lego robot in the learning confine, via Wi-Fi and Bluetooth. And the firmware on the Lego brick has been replaced with the Legos firmware. And it's running a little Java virtual machine on there. Let's take a look at this dashboard. There's quite a bit happening here with the pain and the fear, so I'm going to slow it down and basically work in slow motion, and I've just frozen the frame here. So let's just take a look at the video area over here. So if we look at this area over here, we will see this is now live through the eyes of Troopy, and he's approaching the side of the confine, and you can just see the two colors there. So he's rapidly moving onto the black line now. And I'm just going to move forward a little bit, and then we'll see how he responds to the touching the black line. So we can see him in the video, he's moving closer, and there I'm just going to stop the video there. He's now onto the black line, and if we come to the right here, we can see that yellow graph line shot up there, and that indicates the pain signals are now being fired, and he's now in full pain. If we come over to the left hand side of the screen over here, we will see this area over here. This is the way that it indicates to us that he's experiencing direct pain. This area over here is empty, and we will later see then when he's experiencing fear, we will see the graph there showing some indication of the fear. But this is a clear indication that it's a purely physical experience, very intense, as we can see down here, the facial expression, extreme pain. And as we move forward, so he's now, you can see the reflex on the video there. He's trying to move away as quickly as possible from the from the black line from the wall. He's now experiencing pain. And interestingly, if I just move to this frame over here, we will see now we've had the yellow line, which is the physical pain that he's experiencing. And then we have a fainter pink line over here, which is just initiated a few milliseconds after the pain has been initiated. And this is basically the fear. And in this time period over here, the association forming algorithm has actually started to process the pain and turn it into a fear. And now we can see there's already a fear, and the fear will be triggered by what he's looking at. So the pain is a physical sensation, but the fear will be based on what he's looking at and the association that has been formed with that image. If we move forward a little bit more, we can see now we see the pain has diminished. He's now moved away far enough from the black line so that the physical pain is slowly diminishing. It's not switching off immediately, just like any pain. It will linger a little bit, but we've allowed not too much time for that, because we didn't want that to interfere with the rest of the other tests that we're doing. So we let the pain diminish quite quickly because we want to study what the effect of fear is. That's the pink line over there. Now we see the fear is still lingering, of course, because he's still recognizing those two colors there, which is now associating with pain. If we move a little bit further down the line, we see now he's really moved away. The visual image has changed, and the fear is now diminishing. Interestingly, down here in the general happiness curve, it's a bit blurry, but we can see that the blue curve has now jumped up, which indicates immediately a better state of mind. He's happier. And also, if we come right across over here, we can also see he's in much relief and he's in a much better state here. And interestingly, just to explain why he's actually feeling happy over here, is that the robot was originally in play mode, and that indicates that he's got no real worries in life. So he was not hungry, he was not thirsty, he was not scared or angry, and he was literally in a mode normally he would have been playing, and in quite a happy and high spirits. So he's back there now. Both the pain and the fear has gone, and he's in that mode. So having seen Droopy experience pain by colliding with the confined wall, let's now see if he's actually learned anything from his experience. So he's backed off from the confined wall now, and I'm just going to let him approach the wall again. He's moving forward now after his pain experience. Look at the video, we can see he's moving into that exact same area, getting very close to the wall, moving into that area. And there we see, interestingly, you see that the moment the same colors come up, he's starting to generate these fear states here. These are these pale pink lines, showing that he's starting to recognize those and associating them with the pain. So there's the fear coming through. It's not very clear at this stage in his mind that this is causing pain, so he's learned, but he'll probably have to bump into that area once or twice or three times more, and then it'll become an overwhelming fear sort of association. But as he moves closer, we can see it becomes stronger, and as he moves closer to that colors, we see the pink line becoming stronger and more dominant in his mind, and in this way, fear will manifest. The only reason why it's not a constant fear line is that this has got to do with his ability to recognize, and he's not 100% sure yet. But like I say, the one or two further sort of collisions with a wall in that area, and there will be no doubt in his mind that this is a source of pain, and he will generate very, very strong fear states, which will drive his behavior and which will drive him away from the wall. So concluding on pain and fear, I think we've demonstrated that the Xzistor concept brain model allows us to generate pain and fear in physical and virtual robots. So this is a genuine subjective sensation that the robot will experience, just like you and I. It'll be real pain, and from that he will make the associations that will lead to real fear of the pain that was experienced. It also gives us a simple explanation of how all types of fear work. Remember, I said there's a single simple term that the Xzistor concept brain model defines. Let's just call it ABC, which allows us to explain all different types of fears and derivatives of fear, and even things like the fear of fear. It also explains the transactions between the sensory, the association area, and the emotion-forming algorithms to turn pain into fear. And it shows why pain cannot be recalled. Only fear can be recalled. So a lot of these things are explained by this specific algorithm. We have shown many different tactile, pressure, and proximity sensors can be used. And probably most importantly, this developing this algorithm has given us great insight into why so much of human behavior is driven by fear. And it's really true that fear and different types of fear and derivatives of fear really dominate human behavior. It even goes as far as just unlocking your front door and walking into your house. There's subtle sort of remnants of fear that help you to avoid bumping into walls and into furniture and other objects, hurting yourself in the kitchen, burning yourself, cutting yourself. So it's quite phenomenal how much of our behavior is driven by fear. And perhaps in a later video we can look a little bit at the interesting effect that alcohol and drugs have on addressing these fears, and how that transaction takes place to actually diminish fear and change our behavior. So I think that's about it for pain and fear. This is Anna from the Xzistor Lab signing off. See you in the next video.